It's difficult to predict the life. Nothing in this life is certain. In everything we do, we measure the chances of successful outcomes. A probability provides a quantitative explanation of the chances or the likelihood associated with the various outcomes. It provides a bridge between descriptive and inferential statistics. Now let's look at the content of this video. In this video, we are going to discuss the theory of probability, basic concepts of probability, approaches to probability, and the basic probability rules, conditional probability, and finally, we are going to do mathematical areas with regard into the problem solving with the application of the probability. Let's focus on the theory of probability. Theory of probability is the study of random experiments including different ways to measure the likelihood that a particular outcome or event will occur. Probability has a wide variety of applications in real life. Some of the common applications that we see in our everyday life, such as choosing a card from a deck of cards, or flipping a coin, or throwing a dice in the air, or pulling a red ball out of the bucket of red, white and yellow balls, or winning a lucky draw, can be identified. Let's see what are the basic concepts of probability. The first concept is the experiment. It is any process that generates a set of results or outcomes, such as tossing a fair coin or defect occurring by a production machine. The next concept is the sample space. It is the set of all possible outcomes or results that cannot be broken down any further. The elements in this set are called sample points. Just take an example of experiment of tossing a die. So you know that when we are tossing a die, each die have 6 sides, that is from 1 to 6. So the sample space contains the sample points from 1, 2, 3, 4, 5 and 6. So these are also known as the elements. Event is any collection of results or outcomes of a procedure. Sample event is an outcome or an event that cannot be further broken down into similar, smaller components. Compound event is an event having 2 or more simple points in a composite or compound event. So now you can see the die tossing task as example. So here the simple event we can see it's starting from 1, 2, 3 up to 4 sides. Then the sample space we can see it's starting from the event 1 to 6. So the sample space is denoted with letter S is with each and every event. Now I am going to elaborate an event. An event is a collection of one or more simple events. So let's take this experiment of die tossing. So now we are going to identify 2 events. Event A is getting an odd number. Event B as getting a number which is greater than 2. So you know that in the die tossing task, so we can get either a side from 1 to 6. So in this one, the odd number should be either we should get 1, 3 or 5. So the event A The sample space would be E1, E3 and E5. Now let's see event P, that is getting a number greater than 2. So greater than 2 means either we should get 3 or more, which means either 3, 4, 5 or 6 should be there. So let's see the notations for probabilities. Always P denotes a probability, and capital A, B and C etc. will denote the specific events. And when we are getting P within bracket A, it denotes the probability of event A occurring. The probability of an event A is equal to the sum of the probabilities of the simple events contained in A. If the simple events in an experiment are equally likely, you can calculate probability of A by taking the number of simple events in A divided by the total number of simple events. That is NA divided by the capital N, which contain the total number of simple events. According to the theory of probability of an event A must be between 0 to 1. If event A can never occur, then probability of A is always equal to 0, and if event A is always occurs, then probability of A should be equal to 1. The sum of the probabilities of all simple events in S should be equal to 1, which means the probability of an event A is founded by adding the probabilities of all the simple events contained in A. Now let's identify another key terminologies of the probability, that is mutually exclusive and independent. Mutually exclusive indicate that two events cannot happen at the same time. When a coin is tossed, there are two events that can occur. Either it will be a head or tail. Hence, both the events here are mutually exclusive. Therefore, probability of A and B is equal to 0. In an independent event, the probability of one event does not change based on the outcome of the other event. For example, if we flip a coin 2 times, in the first time it may show a head, but in the next time when we flip, the coin will give an outcome of either head or tail. Hence, we can say the first event does not affect the occurrence of the next event. Thus, the occurrence of head or tail on both sides of the coin are independent to each other. Therefore, probability of A and B can be getting by probability of A into probability of B by multiplying them together. Intersection of two events A and B is the event that both A and B occur when the experiment is performed. It can be seen by A intersection B. If the two events are mutually exclusive, then A intersection B is always equal to 0. The union of two events A and B is the event that either A, either B or both occur when the experiment is performed. We write A union B as follows. The complement of an event A consists of all outcomes of the experiment that do not result in event A. So we can write A complement C like this. So you can see A of the event by in the green area. So A complement C is out of that A boundary. Do you know that there are three approaches to the probability? There are classical approach, relative frequency approach, or also known as experimental probability, and the subjective approach. In the classical approach to probability or in theoretical probability, we assume that an experiment has equally likely possible outcomes. The probability of a simple event happening is the number of times the event can happen divided by the number of possible events. Now, I'm going to explain the classical approach to probability with some examples. So there are many examples we can relate to the classical probability, such as rolling a die. So in the dice, you can see there are equal probability of obtaining numbers from 1 to 6. Therefore, the probability of getting either any number is 1 over 6. When flipping a coin, we can get either a head or tail. Therefore, the probability of getting head is half or 50% and the probability of getting a tail is half or 50%. When we are drawing a card from a deck, getting a card is 1 over 52 since there are 52 cards in a card deck. So just see, there may be multiple choice questions in a question paper. So selecting an answer for a multiple choice question is depend on the number of options in the particular question. So if you are going to form a committee, then choosing a people for the board of the committee is depend on the number of members in the particular committee. Experimental or relative frequency probability is the second approach. Experimental probability relates to the outcome of an experiment or trial. Here, an experiment is repeated a number of times and count how many times the outcome of the trial in the event is set. Because it is experimental, it is possible to get different relative frequency every time that we repeat an experiment. Then the probability is approximated by finding the relative frequency. Therefore, probability of A can be get by taking the number of ways A occurred divided by number of times the experiment was repeated. So such as if you flip a coin 1000 times and if it landed on head 479 times, then the experimental relative frequency of the head is 479 divided by 1000. Now let's use this example to identify the experimental probability. So a computer store tracked the daily sales of laptop computers in past 30 days. So in the first column, the number of laptops sold you can see, and in the second column you can see the number of days. Altogether, these days are add up to 30. So you can see there may be days there are no laptop may be sold by the computer store, and there may be days there are 5 or more laptops are going to sell. So let's find the probability. So you can see, since there are 30 days, we can take that 0 laptops sold probability as 1 divided by 30 or 1 over 30. That is 0.03. So there may be days one laptop is sold. So since there are 2 days, we can take 2 over 30. That is 0.07. There may be days 2 laptops sold. Since there are 10 days like that, we can take 10 divided by 30. That is 0.33. So thus, by using this example, we can see there are 40% chance that the store will sell 3 laptops in a given day, which is calculated by 12 days divided by 30. The final approach is the subjective probability. The probability of event A is estimated using previous knowledge or the degree of belief, or maybe it is someone's opinion or the gut instinct. Such as, someone may claim that their favorite cricket team has an 80% chance of winning the next game. It is their belief. Or the analyst may look at the past trends and current market conditions and estimate the probability of the share price of the particular share will hit all the time height at 20%. It may be based on the previous knowledge. Let's look at the key area of the presentation, that is the basic probability rules. So the first rule is the possible values for probability is ranging from 0 to 1. 0 means there may be impossible events or the mutual exclusive events, and 1 is a certain event or an independent event. The number of all the probabilities for all possible outcomes is equal to 1. And the addition rule. The probability that one or both events occur in the case of mutually exclusive event is probability of event A plus the probability of event B. And in the case of not mutually exclusive events, probability of A add to the probability of B, then we are going to deduct the intersection of probability of A and B. In the fourth rule is the multiplication rule. The probability that both events occur together in the case of independent event is probability of A into probability of B. And it can be taken by probability of A into probability of B given A. Now let's look at the final condition, that is the conditional probability. Probability of an event happening given that another event has already happened can be taken by probability of A given B. In this one, first we are going to take the intersection of probability A and B, and then we are going to divide it by the probability of B. Let's see some practical problems of the probability. Now let's see, if we toss a fair coin twice, what is the probability of observing at least one head? You know that when we are going to flip a coin, there may be 2 possible outcomes, that is either getting a head or tail. And in the second time, still we have 2 options. Either we can get head, either we can get a tail. So probability of each event can be get by head head, head tail, tail head, and tail tail. So probability of getting each is 1/4. That is half into half. So probability of at least one head means we have to take only these two options. In these two only we can have at least one head, and in here we have both heads. So you can see at least one head means we can have either one head or more. So the probability of at least one head is 3/4. Let's imagine a bowl containing 3 marbles, one red, one blue and one green. A child selects 2 marbles and random. What is the probability at least one is red? So here, when the child is taking in the first choice, he may get either red, blue or green marble. And if we select the red marble first, then in the second time there are only 2 options, that is either blue or green. If the child is select the blue marble in the second time, he may have only 2 options, that is either red or green. In the second time, and in the third time, if the child select the green marble first, then he have 2 choices, that is either getting a blue or either red. So event probability is either red or blue, red or green, blue or red, blue or green, green and blue, and green and red. Since there are 3 marbles, probability of each event is 1/3. So probability of red in the first scenario is 1/3. And 1/3 into 1/3, we are getting 1/6. Likewise, we can calculate the probability of each event. Now here, the question is, what is the probability of at least one is red? At least one is red means we can get one red or either 2 may be red. So the probability is 2/3. Now can you see the sample space of throwing a pair of dice? So you know that in a die there are 6 sides, that is 1 to 6. So either you may get 1 in both of the dice, or either you may get 6 in the both of sides, or you may get 1 and you may get 2 in the second die. Please look at this picture carefully. Now look at this table carefully. So you know that each number have the probability of getting 1/6 in a die. So when we are throwing a die, we can get 1 by 1/6 chance of probability and 2 1/6 chance of probability. So here, when the die add up to 3 means either we should get 1 or 2. So there are 2 events we can get the addition of 3. So each event have the probability of 1/6 into 1/6, that is 1/36. Since there are 2 possible events, we can get the total probability as 2/36. So die add up to 6 means either we should get 105, 501, 204, 402 and 303. So you can see there are 5 simple events. We can get the addition of 6. Therefore, the overall probability is 5 by 36 or 5 over 36. So when the red die show 1 means 1 should be there in the red die always. So when the red die give 1, in the green die it can be either 1, 2, 3, 4, 5 or 6. Since there are 6 simple events, the probability is 6 over 36. Like same as that, the number of green die show 1 can be calculated. So green die should always reflect 1. But the red die value may change. It can be either 1 to 6. Since there are 6 chances, the probability is 6 over 36. Now let's calculate the probability of either getting a red die 1 or in the green die 1. So here we have to apply the addition rule. So that is PA plus PB minus P intersection B. So PA means the probability of getting 1 in the red die. Since we have calculated it earlier, that is 6 over 36. And probability of getting a green die is PB and it is 6 over 36. And probability of getting A and B 1 is 1. That is only option. So the final probability value is 11 over 36. Now let's look at this one. So A is the dice add up to 3 and B is dice add up to 6. We know that these two events cannot occur at the same time. Therefore, these are mutually exclusive events. So probability of A is dice add up to 3. So we can see there are only 2 options. And in the B, we are going to take dice add up to 6. There are only 5 options. Since they are mutually exclusive, we have to calculate the probability A union B as probability of A, which is 2 over 36, and probability of B, which is 5 over 36. Then the final answer is 7 over 36.